Hello again, Tom from Every Step Calculus, everystepphysics.com. Don't forget my physics programs, okay, either, in your college education. This is a partial fraction problem, and I wanted to do this problem here because when the powers in the numerator and the power in the denominator are equal, you have to use short division to do the calculations or do the problem. Also, remember that if you can factor the denominator, then it is a partial fraction decomposition problem. If you can't factor the problem, then it could be something else, integration by parts or use substitution or something else, but not partial fraction. So when we factor the denominator, it comes up to this right here, x times the quantity x plus 1, and so then you can use partial fractions on this. So now about my programs. Here's index 8 to get into the program, my main menu, and when you buy my programs, you're taught how to put the index 8 into here to start the problem, okay? So we're going to do that. Press enter. I'm already at this is a whole menu, A to Z, you know, whatever I found for problems in tests, you know, is in here. This is a partial fraction problem, so we'd scroll down to this with this clover leaf here. So we're going to scroll down to partial fractions. We're going to press enter. I know they're in the program there. We're going to enter the integral in here. To do that, we're going to press alpha first, like alpha, and then the left parentheses, and then x capstan squared plus, just like you see here, times. Don't forget the times between terms and calculators because they don't know what you're doing unless you do that. Now I've already programmed this in here because the simulator might mess up on the end, which has been my experience, and so then you have to do the video over again. So I've already programmed it in. So here's what you've just entered into into my programs, okay? And then I let you have the option of changing it if it's not correct. This one is okay. You scroll. You can press the numbers before the menus here, or you can scroll. I can press number 1 here now, and then it'll go and say OK. So I've factored the denominator. No mistakes there. Write this stuff on your test paper, of course, but this problem won't be in your test because it's just too complicated, but it'd probably be in your homework or something. And of course you should probably just go over it a couple times just to learn it, you know. So I've factored the denominator, and if the degree of the numerator is the same as the denominator, we have to do short division. So I take it as short division. Here's the divisor, here's the dividend, and we're going to divide x squared here into x squared here, which you get 1. X squared into x squared here for 1, which is the quotient. And then second, we're going to multiply the quotient times the divisor times this here. 1 times this, of course, x squared plus x. So here's the x squared plus x here. We're going to subtract that from the dividend, come up with 2x plus 5. Okay. And of course, when you can't divide the x squared into the remainder anymore, then you're finished with the problem, really. So here's the answer: 1 plus 2x plus 5 over the divisor here, x squared plus x. And we're going to set up the partial fraction problem. This is the way you do it. This numerator goes on the left side of the problem. We multiply the denominators to get them. We're going to cancel them out. And here's a little bit of a tricky part, but you got to know this. In other words, here's the partial fractions. So a would be over x, and then b is over x plus 1, just like it is up there. Okay, so you're going to multiply the denominators times the partial fraction. When you take x divided into x, you get x plus 1. So these kind of reverse here, which I'll show you on the next. So the 2x on this plus 5 on the left side, and then you got x plus 1 on the right side plus b times x. Okay. Now we have to expand the right side on these problems, so you're going to multiply a times the quantity here and then b times x. No big deal there. And we come up with this right here. When we do that, now we're going to combine a plus b times x, and then we're going to plus a. Alright, so now we know that a is of course a constant, and 5 is a constant, and the numerator here's 5, that's a constant, and we had a as a constant too, what we figured out, so a is equal to 5, and then 2x is equal to a plus bx. Well, then 2 is equal to ab, and then we sub in a for 5, subtract from the other side, we come up with b is equal to minus 3. Pretty neat there. Take your time on this screen here, just kind of look at what I did for the math there. So the original partials are these, which we just talked about here. Now we're going to enter what we figured for a and b. And those become the integrals here. And we have the integral of the 1, which is the quotient. That's one of the tricks here that, you know, they don't tell you or don't emphasize in the books and stuff. So you say, how did they get that? Where'd that come from, you know? Well, that's where it came from. That's why my programs are called step-by-step, every step calculus, every step calculus. So now we're going to integrate the first. Generally, if you have anything in the x or singular modular, that's a log problem. 5 times natural log of x plus c. The second one is minus 3 divided by the quantity x plus 1 over dx, okay, or times dx. Constants always come out of the integrals first. Always do that in your text paper. That professors like that. You got its u substitution problem. X plus 1 is the u, and the derivative of x is 1. Here's 1 dx, and then of course du is equal to dx. So that's one thing with the u substitution. We get rid of the dx and change it to du. And then we rewrite it. Write this on your paper. We integrate it. Minus 3 times the log of u plus c. And we sub back in for u. And here's the answer. And we integrate the third. Here's the 1 of the quotient. When you integrate that with respect to x, it turns out to be x plus c. So here's the original problem. Certainly the original after short division. And the answer is 5 log of x minus 3 log of x plus 1, x plus c. Pretty neat, huh? Everystepcalculus.com. Go to my site, buy my programs, and you'll enjoy passing calculus. Keep in mind, I'll help you all I can. You can call me on the phone. You can send me your quizzes, and I'll show you how my programs work, or I'll help you with actual calculus too. I know quite a bit about calculus, so I'll help you all I can, you know. And keep my physics programs in mind too. So good luck in your classes, and have a good one.